Hi to everybody. I am honored to be part of this Vedic Maths group. My name is Anna Gerardina Foglino. I have a degree in mathematics. I am Vedic Maths certified teacher advanced level. I am naturopath and expert in bioresonance, homeschooling teacher, goal mapping and life mapping practitioner, a technique to achieve goals with both hemispheres of the brain. My intention is to spread out Vedic math, develop creativity, ability, and respect, and take natural care of the body. The topic of this study is permutations and combinations with Vedic math application. The sentence of Bharata Chatterjee that took my attention was, "The sutra apply to and cover each and every part. In fact, there is no part of mathematics, pure and applied, which is beyond their jurisdiction." The question is, can we apply sutras to the permutations and the combinations? Let's remember what they are. Permutations. The number of permutations of n different things taken n at a time is n factorial. N factorial is equal n multiply n minus 1, n minus 2, until multiply 3, 2, and 1. For example, if we have the three letters A, B, C, the permutation of the three letters taken 3 at a time is 6. So 3 factorial is equal 3 multiply 2 multiply 1, that means 6. So we have A, B, C, C, A, B, B, A, C, C, B, A, B, C, A, C, B. What are combinations? The combination of n things taken k at a time are with n greater than k, n sur k, n factorial divided by n minus k factorial, and n factorial. For example, if we have the numbers 1, 2, 3, 4, 5, how many groups we have with 2 elements? We have to find the combination of 5 elements take 2 at a time. So we have 5 factorial divided by 5 minus 2 factorial and 2 factorial, and that is equal 10. We use by one less the one before to do the calculation. What are dispositions? In the disposition, we take care of the order of the elements. So AB is different from BA. The disposition of n things taken k a time are n multiply n minus 1 multiply n minus 2 until n minus k, the number of the elements of the group, plus 1. So, if we have the disposition of 5 things taken 2 at a time, we have 5 multiply 5 minus 2 plus 1, that means 5 multiply 4 equal 20. Dispositions with repetitions. The dispositions with repetitions is when we can repeat the elements. In the example with the elements 1, 2, 3, 4, 5, we can also take 1, 1, 2, 2, 3, 3, 4, 4 and 5, 5 if we want to form groups of 2 elements. So, the disposition with repetition of n things taken k at time are n raised to k. In the example, the disposition of 5 things taken 2 at time with repetition are 5 squared equal 25. Drawing numbers, it's important to activate left brain and also help us and our students understand numbers underlying reality. It's also a pleasure. If we have the permutation of n elements, we can also write the permutation in reverse order due to the commutative property. So we have n factorial equal 1 multiply 2 multiply 3 until n minus 2 multiply n minus 1 multiply n. Now we choose n equal 12 and 45 degrees. Starting from 1, we draw a segment of length 1, then 45 degrees, and we draw a segment of length 2, 45 degrees, segment of length 3, 45 degrees, segment of length 4, 45 degrees, segment of length 5, and so on. So we have this nice picture. What happens if we square the factorial? We have the square of each number. N factorial squared is equal 1 squared multiply 2 squared multiply 3 squared and so on until n squared. Now we choose n equal 9. We draw 1 squared. In the point we finish, we draw 2 squared. Then we draw 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared. After, we join the dots in this manner, where there is the intersection, and we have the spiral. Some applications. Combinations are useful to understand how many numbers we have to multiply when we multiply numbers near the base. Let's multiply 5 numbers above the base. For example, 102 by 103 by 106 by 104 by 108. This is the extension of multiplication of 2 numbers above the base. We have some steps. First, we find the excesses. 2, 3, 6, 4, 8. And we add 102 plus 3 plus 6 plus 4 plus 8, and we have 133. The second step is to multiply and add the 5 excesses, taking 2 numbers at a time. This means the combination of 5 elements taken 2 at a time. We have 5 numbers and we want the dispositions of 5 elements taken to a time. This means 5 by 5 minus 2 plus 1 equal 5 by 4 equal 20. Here we have all the possibility to 3, to 6, to 4, to 8, and so on. The dispositions are all. For the disposition are important to have 2, 3 and 3, 2. In the combination 2, 3 and 3, 2 are the same things. So the order is important for the dispositions. Because the multiplication is commutative, the order is not important. So we have to divide the disposition by the permutation of 2 elements. The combination of 5 elements taken to a time is equal to the disposition of 5 elements taken to a time divided by the permutation of 5 elements. So 5 by 4 divided by 2 factorial equal 10. Similarly, if we apply the formula we saw before, we have combination of 5 elements taken to a time is equal 5 factorial divided by 5 minus 2 factorial by 2 factorial equal 5 by 4 divided by 2 factorial equal 10. We find the result using the SUTRA by one less the one before. So we have 10 multiplications of the excesses taken to a time, and the result is 200. Third step is multiply the 5 excesses taken to a time. That is the combination of 5 elements taken to a time. We apply the SUTRA by the completion or no completion, and we have 5, 3 equal 5 minus 3, that's 5, 2 equal 10. And we have always 10 possibilities to multiply these excesses, and the result is 820. First step is multiply the 5 excesses taken for a time. So we have 5, 4. Yes, we use always the SUTRA by completion or completion. 5, 4 combination is equal 5, 1 combination, it is 5. So we have 5 possibility and we have 1584. The last step is to multiply the 5 excesses taken 5 at a time. This means only one possibility, and we have 1152. To obtain the result, we remember that we are in base 100. That means 2 figures in every place. We add the report and we have the result. If we have to enter a code number in our phone or computer, how many possibilities we have? It depends on how many figures we have to put in, if the order is important or not, and if we have repetitions. We know that the total of figures are 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We suppose to have 4 figures at times. So we have the combination of 10 elements taken for a time. That is by the formula 10 factorial divided by 10 minus 4 factorial by 4 factorial equal to 110. If we use 5 figures, we have the combination of 10 elements taken 5 at a time. We have 10 factorial divided by 10 minus 5 factorial multiplied by 5 factorial equal to 152. If we take 6 figures, we have the combination of 10 elements taken 6 at a time is 10 factorial divided by 10 minus 6 factorial by 6 factorial, 210. If the order of the figures we take is important, we have to use the disposition. So, the disposition of 10 elements taken for a time is 504. If you take 5 figures, the disposition of 10 elements taken 5 at a time is 3024. If we use 6 figures, the disposition of 10 elements taken 6 at a time are 50,120. If in the code number we want to repeat the figures, we have to use the disposition with repetition. So, if we want to put 4 figures, we have the disposition with repetition of 10 elements taken for a time, that is 10 raised to 4th. If we take 5 figures, we have the disposition with repetition of 10 elements taken 5 at a time, 10 raised to 5th. If we take 6 figures, we have the disposition with the repetition of 10 elements taken 6 at a time. It is 10 raised to 6. Properties and SUTRA. We observe that the combination of 10 elements taken for a time is equal to 110. The combination of 10 elements taken 5 at a time is 252. The combination of 10 elements taken 6 at a time is 210. That means the combination of 10 elements taken for a time is equal to the combination of 10 elements taken 6 at times. The reason is that 4 plus 6 is equal 10. In general, we can write that the combination of n elements taken k a time is equal to the combination of n elements taken n minus k a time. This is the property of the sutra by completion or not completion. Other properties deriving from the sutra by completion or no completion are the combination of n elements taken n a time is 1. The combination of n elements taken o a time is 1. Is this from the sutra by transpose and imply? The combination of n elements taken 1 at a time is n. For the factorial product of combinations, we use the sutra vertically and crosswise. The combination of n elements taken k a time multiplied by the combination of m elements taken l a time is that first we crosswise and do factorial. So we have m factorial divided by L factorial multiplied by m factorial divided by k factorial. The second step, we crosswise subtract from the step before, and we have the other part that is the denominator. So we have 1 divided by n mn k factorial by m mn l factorial. So we have the solution. We can find other properties. The combination of n elements taken k time is equal to the combination of n minus 1 element taken k min 1 a time plus the combination of n element minus 1 taken k a time. This comes from by one less the one before. By the sutra multiplied by the rest, we have that n element taken k plus 1 a time is equal an element taken k a time multiplied by n minus k divided by k minus 1. So, in this case, we can find the class that comes next. Cycle permutation. In how many ways and people can stand to form a ring? The sutra we use is by one less the one before. The permutation of n element cycle is n minus 1 factorial. The linear arrangement of n things are n factorial. When we have a circular arrangement, we have to divide by n. In fact, in a circle, the permutation of n element cycle is equal n factorial divided by n equal n minus 1 factorial. Let's look at an example. There are 20 people around a table. In how many ways can they stand to form a ring? We can only shift the people, not change the order. So we have the first arrangement, 20, 1, 2, 3 until 19. Then we shift and we have the second arrangement, 19, 20, 1, 2 until 18, and so on. We can't change the order, so we have to divide the 20 factorial by the number of the people, 20. And we use the sutra by one less the one before, and we have the permutation of 20 person in cycle is 19 factorial. We know that the combinations and permutation are used in the binomial theorem. Here the nice formula. In statistics and probability, another application that can be interesting is the Bernoulli distribution. In probability theory and statistics, the binomial distribution with parameters n and p is the discrete probability distribution of the number of successes in a sequence of n independent experiments. This distribution best describes all situations where a trial is made resulting in either success or failure, yes or not. Here the probability mass function, and thanks to the binomial, we can find that the summation is 1. The question was, Can we apply sutras to the permutation and combinations? Now we have the answer. Yes, we can apply sutras to combination and permutation calculus. Here are the references